Hello, welcome back to my class. So today I'm going to talk about inequalities in one variable. So let me give you an example. Let's try to solve 3x plus 7 greater than or equal to 1. How do you solve this one? Well, there's an equal sign. Basically, we treat it as equal sign except for if you multiply or divide a negative number, you need to reverse the sign. Okay, in this case, we don't need to worry about that. Let's try to solve it. So we want to subtract 7 on both sides so we can get rid of the 7. I have 3x greater than or equal to 1 minus negative 7. I have a negative 6. And then I divide it by 3. Since there is no negative sign, we don't need to flip or reverse the sign. So for x or greater than or equals to negative 2. So you can either write it into interval notation or you can draw a graph. From now on, I'm going to require you to do both so that we can learn both things. So in the interval notation, that means x greater than or equals to negative 2, that means it's bracket because it's including 2 to infinity. So on the number 9, it should be what? So this is infinity. On the other side is negative infinity. Since 2 is including, we have a solid dot and then to infinity. Highlighted that part to the right. So now let's try another example. I'm going to use also red is fine. So I have, okay, here's another example that we need to reverse the sign. So I have a 12 minus 4x less than 6. Okay, to do this one, we need to subtract 12 on both sides. So we have a negative 4x less than negative 6. And now we have a negative 4. We want to divide negative 4 on both sides. However, after dividing the negative 4, you need to reverse or flip the side. So I have what? X greater than negative cancel out. So I have 6 over 4. I simplify, I have 3 over 2. So x greater than 3/2. Write it into an interval notation. I have x greater to 3/2. So that means it's parentheses 3/2 to infinity. Why is not bracket? Because there's no equal sign. 3/2 is not including. Okay, so on the number 9, I have infinity, 0, 3/2, and here approximately 1. So everything to the right. But when it comes to 3/2, it has to be a circle because it's not included. So let's see how does these inequalities apply to our business world. Okay, here's an example. A company spends $1,200 per day on overhead and labor, and each item they produce costs $5 for materials. If they sell the item for $15 each, how many items will they need to sell each day for their profit to be positive? Okay, so in business, profit equals to what? Profit equals to the revenue subtract the cost. Okay, what would be the revenue? If we let n be the number of the product that the company sells. So the revenue equals to what? Each items they sell what? $15 per each. So I have a 15 times n. So the cost equals what? So the company, the fixed cost is going to be 1,200, and plus the various costs, which is $5 per items for material. So the total cost should be 1,200 plus 5M. So the profit equals what? Okay, so profit is equals to the revenue subtract the cost. Okay, this is right. This looks right, but there's a catch. We want to subtract the cost, the total cost. So don't forget the parentheses. If you forget the parentheses, the sign inside the parentheses is going to change, because this whole part inside the parentheses is the cost. You're not just subtracting 12,000, no, 1,200. You're trying to subtract the whole cost, which is 1,200 plus 5M. So in that case, our profit equals to this, and we want this to be positive, which means we want this to be greater than 0. Okay, so now let's merge the like terms. I have a 10N minus 1,200 greater than 0, and then I add 1,200 on both sides. And then divided by 10 on both sides. So N has to be greater than 120. So that means the company will need to sell at least 120 items a day to make a profit, at least. Okay, so the next part of this chapter, we're going to discuss about compound interest. Compound interest means you're going to have interest for both sides. So for example, in here, I have negative 3x plus 5 less than 14 and greater than negative 1. So how do you solve compound interest? So compound interest basically is the same as the compound inequality. So compound inequality basically are the same as the simple inequality, the one variable inequality. But it's just when you're trying to eliminate one number or coefficient, you need to do it on both sides. Such as I want to eliminate the 5. What I need to do is I need to subtract 5 on here, here, also here. The left, middle, and the right. So when I eliminate it, I have what? Negative 1, subtract negative 5, I have negative 6 less than 3, negative 3x less than 9. And then I divided by negative 3 on both sides. So divided by negative 3, divided by negative 3. What will be the catch here? When you divide it by negative 3, what you need to do? You need to flip the side. So you flip it or reverse the side. So I will have 2 greater than x and x greater than negative 3. So let's draw on the number 9 and see what does it look like. On the number 9, negative infinity, infinity. So here's 0, 1, 2, 3. Negative 1, negative 2, negative 3. So okay, 2 is greater than x. So on the other hand means x is less than 2, right? So that means x less than 2 is here and to the right. Okay, and then the other part is what? X is greater than -3. In here, oh, sorry. In here, a circle, but greater than -3, which is this part. So which part do they intercept, overlap? The overlap part is in here, right? So that means if you write it in the notation, it should be from -3 to 2. That would be our solution, the overlap part. Remember, this part, they're not including the 2n. That means we need to use a parentheses instead of a bracket. Okay, what about absolute value function? So when you think about absolute value function, fx equals to absolute of x. So that means if x equals to 1, fx equals to what? 1, right? If x equals to 2, fx equals to 2. So if x equals to any positive number, fx is going to equal to that number, correct? But what about if x equals to -1? Well, if you absolute value of -1, fx equals to 1. So if x equals to -3, fx equals to 3. If x equals to -100, fx after absolute value, this is equal to positive 100. So that means if x equals to a negative number, fx is equal to what? Negative x, right? You take negative of -1, you get 1. You take negative of -3, you got positive 3. You take negative of -100, you will have a positive 100. So that means when we defined a absolute value function into piecewise function, we have x equals to x if x is a positive number or equals to 0, or this is equal to -x if x is less than or equals to 0. On the graph, this is equal to that, like a V shape. Because when everything equals to greater than or equals to 0, which is on the right side, the function on this side should equal to y equals to x, right? Which is our identity function. And then on the left side, this is basically equals to x equals to -x. It's the reverse or the mirrored of the identity function. Okay. So to describe all the value x within the distance of 4 from the number 5, how would you do it? So let me draw a number 9 first. Let me write down the question. If I want you to describe all the values x within a distance of 4 from number 5. So let's draw number 9. What does it look like? So if this is our 5, I have 6, 7, 8, 9, 10, 11, 4, 3, 2, 1, 0. Okay, we're starting from the number 5, right? And then we want the distance within 4. So that means any number, if 5 to the 9, this part, we will consider what? This is the value of x, this part, right? But since it's distant, they could also be this part. Correct? Think about that. So if you think about 4, so from 4 to 5, the distance is what? It's 1. From number 4 to number 5, the distance is 1. So that is still the value of x, even though it's the other side of the distance. So that's really interesting, right? So that means when we're trying to discuss, how do you trying to think about, hey, how to write this down? So we want the distance x and 5 to be less or equal to 4. So that means when we're trying to describe distance, we usually use a absolute value, right? So that means x minus 5, this distance, we want it to be within 4. Okay, let me give you Okay, here's the example that we have. In a 2010 poll reported that 17% of Americans believe that people who are gay should be able to serve in the U.S. military, with a reported margin of error of 3%. The margin of error tells us how far off the actual value could be from the survey value, expressed as a set of possible values using the absolute values. So there's 3% margin of errors. So that means in reality, this is from the poll. So in the true statistic, so maybe 77% of Americans believe that, hey, people are gay should be able to serve the military. Or on the other hand, which is 80%, that's still within 3% margin of errors from 78%. That they can serve the military. So if we let this to be S, so this should be what? S subtract 78% should be less than or equals to 3%. Okay, so now let's try to solve absolute value equations. If we have absolute value, such as I told you that, hey, absolute value of x equals to 4. So x equals to what? X can equal to either positive 4 or x equals to negative 4, right? They have two possible solutions. If I have what? 2x minus 6 equals to 8. So I have what? Either 2x minus 6 equals to positive 8 or 2x minus 6 equals to negative 8. And then we solve for both. Either they equal to 7 or x equals to negative 1. So that means an equation of form that, hey, absolute value equals to such number, they will have two positive solutions. Okay, what about this one? I have 0 equals to 4x plus 1 absolute value minus 7. They basically is the same as a linear equation, right? You add 7 on both sides. So I have 7 equals to 4x plus 1. And then try to remove the absolute value. We will have what? Either 4x plus 1 equals to positive 7 or 4x plus 1 equals to negative 7. And then you solve the two equations respectively. So I have either x equals to 3/2 or x equals to negative 2. I skipped the calculation process here. I feel like by now you should be able to do it. If you're not sure, try to calculate it by yourself and then check the answer. Okay, so now let's try to solve an absolute value, an inequality in solving absolute value inequalities. So if I tell you that, hey, x is absolute value of x less than 4, what's the value of x? Well, what would be possible? They can be what? 1, 2, 3, 4. Not 4. To 3.9 or 3.99999. right? All the positive number for sure. What about the negative one? If you take negative 1, that's still less than 4, right? If you take negative 2.5 of x, absolute value of negative 2.5 still less than 4, to what? Negative 3.99999, right? So that means when we're trying to solve absolute value of x less than 4, s should be what? In between 4 and negative 4. What about the other direction? If I told you that, hey, absolute value of x greater than 4, what will be the possible solution? Greater than. So you can be 5, right? 4.1, 100, and 200, right? So we know that, hey, x has to be greater than 4. What about the negative sign? Well, the negative sign will have, if x is negative 4.1, take absolute value of negative 4.1, this is going to be greater than 4. If x is equal to 6, negative 6, you take absolute value of negative 6, this is greater than 4. But what if I try negative 3.2? If I take absolute value of negative 3.2, this is not going to greater than 4, right? So that means this one doesn't work. And then if I take negative 100, you take absolute value of negative 100, this is greater than 4. So that means x has to be what? S has to be less than 4. Oh. So now let's try to draw a number 9, and what does it look like? If absolute value of x is less than 4, so that means s is going to be in between this interval from negative 4 to 4, parentheses, not a bracket. But if I tell you that, hey, absolute value of x is greater than 4, so that means x is going to be either greater than 4 or less than negative 4. Try to think about that. Okay, so here's an example. If I have what? X less than 5, x minus 5 absolute value, and then less than or equal to 4. Solve for x. So this is less than. That means this is going to be in between when I remove the absolute value sign. So I have what? S minus 5 less than or equals to 4, or greater than or equals to negative 4. And then I add 5 on both sides. I have x less than or equals to 9, x is greater than or equals to 1. So on the number 9, this is going to be from 1 to 9, including, so bracket or solid dot. Okay, let's try another examples. So if I want you to solve negative 2 absolute value of k minus 4 less than or greater than negative 6. How to solve that? Well, first of all, you divide it by negative 2 on both sides. When you divide it by negative 2 on both sides, what do you get? You need to reverse the sign because there's a negative number. So negative 2 get cancelled. I have absolute value of k minus 4 greater than or equal to 3. Okay, this is greater sign. So that means the graph is going to look like 2 and, right? not in between. So I have either k minus 4 greater than or equal to 3, or k minus 4 less than or equals to -3. Okay, and then we solve it individually. I have adding 4 on both sides. I have k greater than 7, or k, I add 4 on both sides, less than or equals to 1. So on the number 9, these should be 0, 1, 2, 3, 4, 5, 6, 6, 7, 8. Okay, so x is greater than 7, solid dot greater than, so to the right, because this is in positive infinity, or x is going to less than or equals to 1, so that means from 1 to negative infinity. Okay, so on the bracket, on the interval notation, this should be written as negative infinity to 1 bracket union bracket 7 to infinity. So on the previous example, if we want to write into an interval notation, this should be from 1 to 9, bracket and bracket. Okay, that's it for today's lesson. Let me know if you have other questions.